Motion with stops on a graph. Motion so far has stayed consistent over time. Therefore, the graphs have been linear, like the example below. Consider what will happen to the graphs visually if there are breaks in the motion. For example, a car traveling at a constant distance every second stops at a red light. During the time that the car is stopped, the distance traveled would not increase. In other words, the time will lapse, but the car would not have gone any further. Graphically, this would appear as a horizontal line on a distance time graph. Let's look at an example. A car travels 5 meters every second for 5 seconds, then stops at a red light for 5 seconds, then continues to drive 5 meters per second for another 3 seconds. Graph this scenario. First, let's plot the first part of the trip. The car travels 5 meters per second for 5 seconds. Notice how for every 1 second horizontally, the line goes up 5 meters vertically. Now let's consider the 5 seconds stopped at the light. During the duration of the 5 seconds, shown here in red, the car does not increase its distance traveled. We represent this with a horizontal line for 5 seconds. Finally, the car begins to travel again for another 3 seconds at a speed of 5 meters per second. This is shown by continuing the line 5 meters vertically for every 1 second horizontally. What if the car decided to turn around and drive back 5 meters per second from the way it came? So the car actually traveled 5 meters per second for 5 seconds, then stopped at the light for 5 seconds, but then turned around and traveled for 3 seconds back at 5 meters per second. Let's graph this scenario. The first 2 parts of the graph would look the same. You travel for 5 seconds at 5 meters per second, then stop for 5 seconds. This time, however, the car turned around and decreased its distance traveled by going back the way it came. So the pace is the same, but the line needs to show that the distance has decreased.